It measures my 66.5 kilo ohm reference resistors as 60. It measures my 60. Welcome everyone, review time again. Today we are taking a closer look at this pocket multimeter. It's the Aneng AN302 8000 count through RMS multimeter. Now you can't see anything, but I need to get it out of this protective packaging. It comes with this black pouch, and inside the meter is wrapped in some bubble wrap. I don't know about you, but when I'm receiving stuff from China, it always contains this popped bubble wrap. Have you noticed the same? I wonder why the bubble wrap is already popped, because it kind of defeats the purpose of protecting the item inside. But 100% of the cases I'm getting stuff from China, it has this kind of bubble wrap which is already popped. So here is the meter. This video is sponsored by JLC PCB, a professional manufacturer of printed circuit boards. Their website is modern and has convenient features like easy-to-use order form with built-in Gerber viewer, production process tracking, package tracking, and single button reorder for previous orders without having to upload Gerber files again. We can see it's marked Cat 2 600 volts, Cat 3 300 volts. It's made out of plastic and doesn't feel like good plastic. It's more on the cheap side. You can also get it in a red color, and that might be a good option. You might spot it easier in a box of tools. There is some resemblance with the Bryman pocket meters that we've reviewed here. Here is the Bryman BM22S. I'm not sure if they're copying the Brymans, but one thing is certain, they're exactly the same size. So one could wonder who are they copying with this design. The Aneng has this hooking clip on the top, and it comes with this cheap lanyard, but who would do that? Who would carry their multimeter strapped to their wrist using this lanyard? I wouldn't. As we know, Aneng is not a multimeter manufacturer. They just rebrand stuff made by someone else. And for example, if we look on the manual, there is no branding here because they probably ship this universal user manual. No matter what brand they write here on the multimeter, they ship the same user manual from the factory. So there is no branding on the manual itself. There isn't any UL listing on this meter, so there probably isn't sufficient protection on the input section of this meter, but we'll check that later in the teardown. The killer function in quote marks for this meter is this flashlight on the back. Yep, you heard it right, this meter has a flashlight on the back. There is a reason pocket multimeters don't have a backlight. That is to save on battery life, because they usually run from coin cells battery, but no, on this model they decided they want a flashlight on the back, even though it's powered by a coin cell. We'll measure the current draw with the flashlight on later when we do the teardown, but I imagine that's going to shorten the battery life of this meter. The meter does not have a rotary switch like the other pocket meters we've looked at, and I don't mind that idea as long as it gets the job done. But I have already noticed an issue. So the on-off button and the function button are latching mechanical switches. Just hear that. So when you press them, they actually activate a mechanical switch, while these others are soft switches. And sometimes the on-off button just happens to catch, you see, like that on the inside of the case, but I've tested it and it doesn't appear to affect the functionality. It's just the rubber button that does that. The mechanical switch underneath is switching just fine. So it's I thought it's going to be an issue, but it's not. We have a manual range option, which might be useful for some of you. I rarely use that function, but I understand its importance, and it's here if you need it. You also have a hold function, which I never use, and a relative button that is very useful, and I use whenever I have to measure resistance to cancel out the resistance of the leads. There is an auto power off function. It's mentioned in the manual, but they don't tell you the interval. I've seen it turn off at approximately 30 minutes. Pressing the blue function button will allow you to select between the two menus. So one of them is for millivolts, ohms, diodes, continuity, capacitors, and frequency, and the other one is for DC volts, AC volts, and NCV detection. The LCD looks good. It has some nice big crisp digits. It looks nice from a 6 o'clock viewing angle. It looks okay from the sides as well, but it starts to fade quickly when you view it from above. I like how they have the sign and the AC/DC indicator right in front of the digits. That's a nice layout, and we have a refresh rate of 3 updates per second, which is pretty common with these pocket meters. The NCV function is very sensitive. It beeps even if I bring my hand close to it, but it works. It's not a problem like with the previous Unity meter where it was unusable. And the thing is, when the NCV function triggers, the LED on the back also lights up, so that will drain your battery faster, but like I said, it's usable. You can also activate the flashlight with a long press of the hold button, and it's just a small LED. It's not even usable. I don't know why they went for this option anyway. It's a stupid option considering the CR2032 battery that powers this thing. The test leads have about 70 centimeters of cable. It's PVC, but it feels good. It's like decent PVC wire. It does have ratings on the cable. They say 600 volts, 105 degrees C. And on the probe themselves, we have markings and they say max 250 volts Cat 3, while on the meter we have 300 volts Cat 3. So there's a bit of confusion here, but you wouldn't want to connect this meter to anything more than 250 volts anyway. I like how the leads exit through the side of the meter. It's more ergonomic this way because you could maybe sit it like this and against something, so the leads are not in the way. So I like that they go out on the side of the meter. The test leads are not the worst I've seen, but they don't feel nice either. They're pretty small, not very sharp, probably okay for that remote one measurement only job, but not something you'd want to work with every day. The continuity test is a nice surprise on this meter because it is latched and it puts out about 70 dB, which is a decent sound level. It will detect the two probes touching with their own weight, and it's pretty fast as well. It will catch very short pulses like I'm showing here. Comparing with the other pocket meters, it's a really good continuity tester. The diode test is just enough to turn on a blue LED like I'm showing here at 2.6 volts, but this will of course be limited by the battery voltage, which is 3 volts when the battery is fresh. The auto ranging works surprisingly well, better than what I've seen on the other cheap meters. There is no funny business going on, and it has decent speed as well. On voltage, it goes to the measured value with no overshoot, and the same can be said for resistance measurement. It just goes up to the correct range with no issues at all. In terms of accuracy, we start with the specs, and as usual there is nothing special here. Plus or minus 0.5% and 3 counts for DC volts. We have 1% for AC volts, 0.5% for resistance, 2% for capacitance, plus 5 counts. And these are pretty common figures with pocket meters because they are not meant to be used for high accuracy measurements. It measures my 66.5 kilo ohm reference resistor as 66.5, which is exactly what we want to see. It also measures my reference capacitor, which is 39.69 nanofarad at 39.82 nanofarad, which is well within the specs. And it measures my 5 volts reference, which is 5.004 volts. It measures it at 5.001 volts, which is again well within the acceptable tolerance of this meter. It's accurate enough and certainly meeting the specs. To access the battery, you'll have to remove these 3 screws, which will allow you to remove the back cover. So after removing the back cover, we can see the meter uses a CR2032 battery, which is not included with the meter. I fitted this battery, and the battery goes into this slot right here. And there is a big issue I had here figuring out the orientation of the battery, because there is no marking to let you know how to insert the battery. Just for your information, it should go in like this with the negative facing down. While we're here, let's do some measurements on the power consumption. So the meter doesn't consume anything while it's turned off. Let's turn it on. So on DC volts, it will pull 1.5 milliamps. On resistance, we're pulling 1.7 milliamps. Now let's also check the battery cutoff voltage, because that's important in determining the battery life. We need to know how much of the available energy in a coin cell this meter is going to be using. So for that, I have this Aneng AN302 measuring the battery voltage of the Aneng AN302, and the 302 is on DC volts, measuring this 5 volts voltage reference, just to see if it's usable down to the low battery voltages, if the measurement goes out of spec or not. So I'm at 3 volts now, and I'm gonna start dropping the voltage. Let's see when the low battery sign comes on. Yep, at about 2.3 volts, the low battery sign was shown on the display, and I believe soon we will see the meter turn off. But notice how it's still within spec. It's measuring my 5 volts reference, and it's still within spec. Remember, this meter has a 0.5% accuracy on the DC volts range, and we are on the 8 volt range, so that means we should see a maximum of 40 millivolts of error on this measurement. But since this is a 5.00 volt reference, we are well within spec even at the lower battery levels. So let's see, will it work at 2.1 volts? No, it turns off at approximately 2.2 volts. So a good CR2032 coin cell battery will probably have about 200-220 milliamp hours. So considering our current draw on average of 1.6 milliamps, we are going to get about 120 hours of usage from a single coin cell battery with this meter, which is about half of what we were getting with some of the other meters powered by CR2032 batteries. Those were getting 200 hours of usage. This one is getting only 120 hours, but it has a slightly higher current draw. The good thing though in this test is that the meter continued to measure accurately the voltage, even though we were at almost the point where it turns off, where there is no more energy inside the battery. So you can trust the measurements even with a low battery on this meter. Now I'm also curious to check how much current will the LED flashlight draw. So let's turn that on. and we've jumped to 13.5 milliamps. So that's adding like 12 milliamps to the power draw of this meter, and with a 200 milliamp battery, it's not going to last for very long if you use the flashlight feature on this meter. So, like expected, it's a stupid feature to have on a multimeter. Now for the actual teardown of the meter, we can see the PCB is held down with these clips on the side. There is no screw holding the PCB in. That is a sign of they're trying to save some cost without having some operator install a screw in the production line. We can see the LCD is connected with a zebra strip, and actually there isn't that much to be seen here. But what is this? Is this like a piece of zebra strip? Yeah, I believe it is. It's like some residue from the factory. A small piece of zebra strip remained captive inside the meter. So let's start with the input. The quality of the solder joint seems fine, but there is no crimp on the wires. They are directly soldered to the PCB. That's also a place where they're trying to save cost, and that's something that on a more expensive meter you see done differently. You see the wires being crimped and then soldered to the PCB. Here are the two mechanical switches. They are very compact, and not sure if they were really supposed to be mounted surface mount, or they were through hole, and you see they made this cutout in the PCB and then bent the terminals on the back of the PCB and soldered them. Maybe they are repurposing this, maybe they are through hole switches, I'm not sure. We see code here. This is ZT08. So this meter is that's probably the original name of this meter from the manufacturer that actually designed this meter. And could this be a date code like 3rd of April 2018? I'm not sure. It could be. Here is the blob of epoxy. We don't know what multimeter chipset they're using. I believe this is an EEPROM for storing some calibration data. It's surprising to find this on such a low cost multimeter, but maybe these newer multimeter chipsets, maybe they don't have pins for external calibration pots anymore. Maybe they just use an EEPROM, so they are forced to use an EEPROM. And it appears that we have very few protection in devices in here. We have a small PTC. We have a couple of back-to-back transistors for clamping here. A couple of series diodes here. They are 5 megohms each. And that's about all the protection you get on this meter. And the buzzer is, as usual, one of these very thin piezo buzzers, which is stuck to the back of the case, and it's making connection with these spring contacts. Here is the LED used for the flashlight. This looks like a simple 0603 white LED. Since we've only seen that small PTC as a protection device and a couple of transistors, there is no spark gap, there are no varistors. In terms of protection, this meter doesn't offer much, and it would be better if you would keep it away from high energy circuits. It's a good thing it doesn't have any current measurement capability that takes some of the risk away, but still, if you are measuring, for example, a wall socket rated for 240 volts AC, and just at that unfortunate moment there is a surge on the AC line, a short pulse of over 1 kilovolt, this meter could potentially explode. So now to give you my final thoughts on this meter, to be short, I like it very much. It's got a nice form factor. It resembles those Brymans very much. It's light, it's thin, you can fit it in your pocket with ease. I like that the LCD has nice crisp digits. I like the latched continuity tester, which is probably some of the best I've seen in pocket meters. I like all the different measurement functions it has. I don't like the lack of input protection, but if you avoid high energy circuits, this meter should serve you well. But when you start to consider the price of just $10 for this meter, that's when its value starts to become clear. This meter will take the number 3 spot in my spreadsheet, which will be linked in the description below, meaning it's my new favorite cheap pocket meter. I still like the Bryman pocket meters better, but those are more expensive, they have more protection, so if you can afford them, get the Bryman BM22S or the BM27S, but if you want something cheap that's good and doesn't have any input protection, get this one. It's good value for money. As usual, there will be links in the description to places where you can find this meter. I hope you enjoyed watching this review, and if you did, please hit the thumbs up button which is right below the video. Thank you for watching, and I'll see you next week.